Today we'll start zettili chapter number 3, article number 3.6.4, conservation of probability. We know that Hamiltonian is Hermitian. So it means that the inner product of the state function will be independent of time. And psi of t, it means that psi of t is normalized. It is normal function. It doesn't vary with time. So it is not, this psi of t is not normalized only for a specific interval. It will be normalized for all the subsequent intervals. And this is a direct consequence of the hermicity of H. Hermicity of H means hermicity of Hamiltonian. The inner product of the state vector, which is called the probability, psi of t, bra and ket, inner product, will be equal to integral psi of rt whole mod square dqx. We have to prove that the inner product of the state vector is time independent. As we know that it is time independent, or we have to prove it that it is time independent, so it means that it is not varying with time. So if something is not varying with time, then we take the time derivative of that vector or that function. So also we will use this thing here, that the time derivative, we will take the time derivative of the inner product of the state vector d by dt psi of t, and we will prove that it is that the product is or the state function is not varying with time. It is not varying with time, so it means that with respect to time this function is constant, and constant thing will be equal to 0 in mathematics. So as we take its time derivative, d by dt of bra vector, this one psi of t, multiplied by cat psi plus again bra psi of t, and d by dt of cat. And we know that the value of d by dt, time derivative of cat vector, is equal to minus iota over h cut Hamiltonian and psi of t. Also the time derivative of bra vector is equal to iota over h cut psi bra into Hamiltonian with conjugate. This conjugate is called the complex conjugate. And we know that the Hamiltonian is Hermitian, so it will be equal to H. And we can say that d by dt into the bra vector is equal to iota over h cut psi of t and h vector. We can say this is our equation number 1, this is equation number 2, and this is equation number 3. And we substitute the equation number 2 and 3 in 1, then we get the result d by dt psi of t cat and bra inner product is equal to, we know that here first of all is time derivative of cat, and here is time derivative of bra. So we will substitute the equations here. We get the result iota over h cut psi of t Hamiltonian multiplied by cat vector plus bra vector and multiplied by the value iota over h cut psi of t and h. Oh sorry, here will be minus sign and here will be plus. It's okay. And we take common here this one and this one. When we take common from these two terms, we get this result a over h card plus, sorry, minus a over h card. This one minus is here, and psi of t Hamiltonian and psi of t, this one here, and from here this two will be we will take common psi of t Hamiltonian and psi of t, and we know that these two things or these two terms are same but opposite sign, so it will be equal to 0. And here we get the result that the time derivative of the inner product of the state vector is equal to 0. This result 0 shows that it is constant, and if it is constant then it means that it is not varying with respect to time. And now we need to find out the result that the state vector depend only on the position, not on the time. So for this we will take the Schrodinger equation, which will be time dependent. Rho is equal to psi and psi. This is the current density we know, and is equal to psi star psi. Here we will take the time derivative of this equation. Again I am writing this equation, rho is equal to psi star psi. By taking the time derivative, we get d by dt rho is equal to psi star d by dt into psi plus psi d by dt psi star. We said that this is equation number 4 because it is important. We will